Hi, welcome back to my channel, and for today's video, we will be talking about the cofactor expansion method in solving determinants. So to show you one of my collections of plants, I have one of the Monstera collection here. Just take a look into that. And guys, thank you so much for all your support. So if you are new to my channel, please don't forget to subscribe so that you'll be updated on a lot of videos that I'll be uploading soon. So to start now, we will define this cofactor of a matrix. So given that you have a matrix, so of this size, that's n by n, and we defined this ij cofactor of A, which we denote this by symbol. So this is the ij cofactor of A to be the -1 to I plus j times the determinant of submatrix obtained by deleting row I and column j of A. Example, let's say our matrix here is 3 0 2 1 1 0 1 2 1. So let's say we want to see the 1 1 cofactor of a matrix A. So the 1 1 cofactor of a matrix A is A11 equals, that's -1 to I plus j. So your I and j is 1 and 1, so you have 2 times the determinant of the matrix. This is the submatrix obtained by deleting row I and column j of A. So your 1 1, so the first row here and the first column. So this means this is your remaining submatrix. So you have 1 0 2 1. So this is technically -1 to squared. What's the determinant here? So you have 1 minus 0. So that's basically 1 times 1. So that's 1. So the cofactor of these, the 1 1 cofactor of the matrix is 1. That's it. So how do we use this definition for cofactor for solving the determinant of a matrix? So we will introduce the theorem here. So this is the so-called Laplace expansion definition of the determinant, or sometimes known as the cofactor expansion method. So let A be a matrix, that's an n by n matrix, so it's a square matrix. The determinant of A can be computed using the following for any I or j by this theorem here. So these two formula are actually equivalent. This one, if you want to use this for this is actually cofactor expansion along. So the one that works here is the I, which is the row. So this is along j column. Column j rather. So if this is j here, which is the column, so this is along row I. That's it. So in view of this theorem here, we will consider an example. So let's consider an example here. Let's say our matrix A is 1 -1 1 2 0 0 1 1 2. So we will compute the determinant using the cofactor. But first, to make it more comprehensive, we will solve for the cofactors of A. So let's start with A11. So A11, this is actually -1, 1 plus 1, because the I is 1, the j is 1, so you get 2. And that's the determinant of what is left. So you remove the row 1 and the column 1, so you're left with 0 0 1 2, and basically this is 0. So next is A12, so that's a -1 2 3, so that's determinant of -1 1 1, and 2. So basically, you remove the row 1 and column 2. So this is actually negative 1 times negative 2 minus 1, that's 3. Next is A1, 3. So that's negative 1, 2, 4. That's the determinant of negative 1, 0, 1, 0. So that means you remove the row 1 and column 3. So this is 1 times 0. So that's equal to 0. So next is a to 1. So that's negative 1 to the 3. And that's determinant of... So don't be confused with A1, 2, and A2, 1. Because on A1, 2, you remove the row 1 and the column 2. Here, you remove the row 2 and the column 1. So when you remove the row 2 and the column 1, that's basic. What you left is 2, 1, 0, 2. And this is actually negative 1, 4. So that's equal to negative 4. You also have A 2, 2. So that's negative 1 to the 4. And so this is determinant of, so that's 1, 1, 1, 2. And so this is 1 times 2 minus 1. So you get 1. And this is A2, 3. So this is negative 1 to the 5. So that's determinant of 1, 2, 1, 0. So this is negative 1, negative 2. So that's equal to 2. So 8, 3, 1. So that's a negative 1 to the 4. So you have determinant of 2, 1, 0, 1. So this is equal to 2. So that's 2. And A3, 2. So you have negative 1, 5. That's determinant of 1, 1, negative 1, 1. So you have negative 1, 1 plus 1. So you have negative 2. And lastly, you have A3, 3. So that's negative 1 to 6. That's determinant of 1, 2, negative 1, 0. So that's actually 2. So what's the point of us solving for the cofactors of A? So these are the cofactors of A. Remember that our first goal is to solve for the determinant of A. So meaning to say that either of these cofactors you get, you can just pick one of them to use for the cofactor formula. So remember on the theorem, this is the cofactor formula. So if you want to work with column J or if you want to work with column I. So let's say, for example, I want to work on row 2. So that's row I. So that means the determinant of A using the theorem, that's the summation of A. Your I here is 2. So that's Aij. So yes, A2J. A to J. Okay, so that's J from 1 to 3. So that's basically A to J. So that's A to 1. So that's A to 1. That's A to 1 plus A to 2, A to 2 plus A to 3, A to 3. So what's A to 1? A to 1 here. So this is negative 1, and this is A to 1 plus your A to 2 here is 0. So this is this one here is 0, and you have A to 3. So your A to 3 here from the original entry is A to 3 is 1. So that's 1 times A to 3. So what is negative 1 A to 1? So here is negative 4. So you have negative 1, negative 4, plus 1 times your a23 here is 2. So that is equal to 6. Now, what if I want to solve for, I don't want to use row 2, I want to use column 2. So that's still the same. So that means my j here is 2. So I use the formula for the column j. So that's determinant of A equals the summation of A I2 AI2. So that's I from 1 to 3. So that I would have A12 A12 plus A22 A22 plus A32 A32. So what is my A12? My A12 here is 2, and that's A12 plus my A22 here is 0, that's A22 plus A32 here is also 0, so that's A32. So these are 0. So I would have 2 times, what's A12 here? My A12 is 3. So therefore, this is 6. So whatever you're actually getting, I mean, what method you're actually getting, like you want to work on a column or a row, that's still the same. You get the same determinant as long as you have the correct computation. So just to make sure, we will cite one consideration. Let's say we will consider row that's row is 3. So that means our I here is 3. So the determinant of A is the sum of A3J, A3J, J from 1 to 3. So that's A31, A31 plus A32, A32 plus A33, A33. So what's A31 here? A31 is 1, that's times A31, plus A32 is 0, so that's 0 A32, and your A33 is 2, so that's A33. So here, what's 1 times, what's A31? A31 is 2 plus 2 times, what's A33? A33 is 2. So I get 2 plus 4 and I have 6. So whatever you're actually doing, you are actually getting the right determinant. That's it. Okay, so that's all for now. Thank you so much for watching. So if you have any question or clarification, you can comment down there. So I know I only give you one example here, but if you might want to request for some more, just comment down there so that I would know. And guys, thank you so much for watching. So see you for the next series and have a great day.